Hello everyone, my name is Kalhan and today I will present my machine learning project on human activity recognition by using classifying physical activities from wearable accelerometer data using deep learning. I use Python with TensorFlow, NumPy and Pandas. The project ran on Google Colab with a GPU using TensorFlow version 2.19. This gave me the computing power needed to train a deep learning model effectively. Project classifies 6 activities: cycling, push-up, run, squat, table tennis and walk. Each activity has its own CSV file. The sensor data has 15 channels. 3 axes from 5 body-worn devices sampled at 40 Hz. I set the window size to 60 samples, which equals 1.5 seconds of data. When I loaded the file, I found a serious problem. The push-up file had over 114,000 missing values. 53% of its data was gone. The squat field had 33,000 missing values. If I had left these empty, the model would have completely failed to learn those activities. I fixed this using forward fill and backward fill. Each missing value is represented by the nearest real sensor reading. After cleaning, all 6 files had 0 missing values. I also removed extreme spikes by clipping values beyond 5 standard deviations. I plotted the first 200 samples of each activity across all 5 sensors, and this helped me visually confirm that different activities produce different signal patterns. For example, running and cycling shows strong regular impacts, while push-up shows a slow high amplitude arm movements. I divided each clean time series into overlapping windows of 60 samples with 50% overlap. This gave me 5,968 total sequences. At the first 80% of each activity window went to training and 20% went to testing. This time-based split is important. A random split would allow the model to see future data, giving unrealistically high results. The training data was shuffled randomly because some activities had far more sequences than others. Tennis had 1,804 versus runs 264. I calculated class weight to make sure smaller classes were not ignored during training. I designed a convolution neural network LSTM model with just under 1 lakh parameters. 3 convolutional layers learn local motion patterns from sensor readings. Then an LSTM layer reads the full sequence and captures the overall temporal structure. This is what separates cycling from squat. Finally, dense layers with dropout produce the 6-class prediction. I used focal loss, which forced the model to focus on hard examples rather than easy ones. The model trained for only 9 epochs before early stop triggered. The final test accuracy was 93% 56 with a weighted F1 score of 0.9348. Push-up, run and squat all achieved perfect or near perfect recall. The only significant mistake was 56 cycling sequences predicted as table tennis. Both activities repeated at a similar frequency of 1 to 2 Hz, which makes them hard to separate. The train model was saved and exported to Google Drive along with test sample CSV files and output figures, ready for deployment as a Guardio web application on Hugging Face spaces. That's all about my project. Thank you very much.